Hi, today we're looking at the PAT paper from 2012, going through question 20. So in question 20 we're considering two samples of uranium, uranium-235 and uranium-238. We're told their half-lives, T sub 235 and T sub 238, are 7 times 10 to the 8 and 12.5 times 10 to the 9 years respectively, and the number of particles of each at time t is n sub 235 and n sub 238. We're told to define the ratio r of t to be n235 over n238, and given that r is now 0.0072, asked what was r 10 to the 9 years ago. Okay, so we can start off by defining that the number of 235 particles at time t will be, well, let's define t0 to be 10 to the 9 years ago. So that will be the number n0, 235t, times e to the minus, and then the decay constant, sub 235, times the time since 10 to the 9 years ago. And similarly, we define for 238 it to be the number at time 0, e to the minus lambda sub 238t. Okay, well then this tells us that r of t, the ratio at time t, is equal to, well, let's define r0 to be the ratio of n238 to n235 naught. So r0, e to the minus lambda 235t over e to the minus lambda 238t. Okay, well we're told that present day it is r is equal to 0.0072, so that is 10 to the 9, so that is letting t equal to 10 to the 9, so because we're letting t0 be 10 to the 9 years ago, today corresponds to 10 to the 9. So therefore we know 0.0072 equals r0 e to the minus lambda 235 times 10 to the 9 over e to the minus lambda sub 238 times 10 to the 9. Okay, we're now going to find lambda 235 and lambda 238. Well, we know that half-life, t sub half, is equal to ln 2 over the lambda, the decay constant. Therefore we have, well, lambda 235 is equal to ln 2 over 7 times 10 to the 8. And similarly, lambda sub 238 equals ln 2 over 4.5 times 10 to the 9. Well, we can sub this into our equations, and this tells us that 0.0072 is equal to r0 e to the minus ln 2 times 10 to the 9 over 7 times 10 to the 8, all divided by e to the minus ln 2 times 10 to the 9 over 4.5 times 10 to the 9. Well, we're told in the question, let's write this down here, that we can approximate for small x, e to the x is approximately equal to 1 plus x, e is approximately equal to 2.7, and that ln 2 is approximately equal to 0.7. So let's use those. Well, this is therefore approximately equal to r0 e to the minus, well, ln 2 goes to 0.7, so 0.7 times 10 to the 9, which is 7 times 10 to the 8, over 7 times 10 to the 8, divided by e to the minus, well, ln 2 goes to 0.7, so we get 0.7 and 10 to the 9's cancel, so 0.7 over 4.5. Well, then this is approximately equal to, well, now we get e to the minus 1, so that's r0, and then we were told e is approximately 2.7, so that's 2.7 to the minus 1, divided by e to the minus 0.7 over 4.5, well, that's a small power, so that's going to be equal to approximately 1 minus 0.7 over 4.5. Well, therefore we know, timesing through, r0 equals to 0.0072 times 1 minus 0.7 over 4.5 times 2.7. And this comes out to be approximately equal to 0.016. And that's our ratio at time 10 to the 9 years ago.